Hey everyone, this is our data science project. I'm Franco and I worked alongside Andrei, Hanna, Nathan, and Natalie. We centered our project on a Spotify dataset and aimed to explore it to answer some questions that we had. So this dataset includes songs all the way from 1921 to January of this year, and is marked by various audio features like acousticness, instrumentalness, key, tempo, and more. As you can see below, we found the features that make up Taylor Swift's song, Love Story. A notable variable here is danceability, which describes how suitable a track is for dancing based on a combination of musical elements and is ranked from 0 to 1. As we can see, Love Story has a 0.618 for danceability, indicating that you can dance to it quite well. Another variable like tempo measures beats per minute in a song, which typically ranges from 50 to 150. Love Story, as you can see here, has a pretty high tempo, which is fitting because it's an upbeat song.
To drive the focus of our project, we selected 3 questions to examine. First, we wanted to make sense of our data's features, since there are a lot of unfamiliar ones, such as danceability. Next, due to the large size of our dataset, we narrowed down our scope to just one artist, Taylor Swift. We were curious to see how Taylor Swift's style has changed over time. Lastly, we wanted to see if we could use the features of this dataset to cluster Taylor's songs by album. To answer our first question about exploring our dataset's features, we first had to clean our data. We dropped unnecessary columns, cleaned up row names for easier readability, and took out non-English songs, as a lot of them tended to be novels for some odd reason.
Another aspect of our data exploration was looking at popularity. We found out that the most popular Taylor Swift song was Willow with a popularity score of 89. We also wanted to look at popularity over time. And by digging deeper into this area, we found that this graph is actually misleading because Spotify determines its popularity score by using total plays and how recent those plays are. So that explains why she is consistently growing in popularity and also why there's a sharp drop-off at the very end, because those songs are so new that they have not had enough time to accumulate a large amount of total plays. We also wanted to see if Taylor's style has changed over time. And so we looked at 4 variables: tempo, valence, acousticness, and danceability. With tempo and valence, we did not see clear trends. But recently, Taylor's acousticness has increased and her danceability has decreased. So we decided to run some hypothesis tests to see if these changes were significant.
So our first hypothesis test will be comparing acousticness of old Taylor Swift songs, which is before 2020, and new Taylor Swift songs starting in 2020. This histogram shows the average difference in acousticness if old and new Taylor are the same, and the black dot shows the actual difference between old and new Taylor. Because this black dot is so far to the right above our alpha level of 5%, we have concluded that new Taylor is in fact more acoustic than old Taylor. We then made this hypothesis test a function where we could input any of the audio features to test its significance. Shown in the graphs below, we see danceability, valence, and tempo. In danceability, we conclude that the danceability of new Taylor is less than that of old Taylor. However, valence and tempo could not provide a conclusion based on this significance level.
Next, we wanted to investigate whether we can cluster Taylor's songs by album using the audio features. We clustered the songs using all the numerical features provided by the Spotify algorithm, including acousticness, energy, tempo, and instrumentalness, these being features that we thought might make up distinct song styles. And we chose 10 clusters because Taylor Swift has 10 albums. As you can see when we plotted 2 variables side by side, there are no clear patterns in the data, and there's not clear clusters being formed. Moreover, when you compare it to the actual values, in the actual albums that every song belongs to, for example, looking at the cluster of orange dots on the left, we can see that they are actually made up of songs from varying years, therefore they're from different albums. We hypothesized that this is because there can be songs of multiple genres on a single album. In conclusion, this dataset contains much more than just songs, and there is still more cleaning that we need to do in order to only select the English songs from it. Moreover, we investigated how Taylor Swift's style has changed over the years, and we observed that the new songs are more acoustic and less danceable. However, we could not distinguish each album using only this dataset's combination of features. For future work, we want to also explore how other artists evolve over time, and maybe even explore the evolution of entire genres. Thank you so much for listening, and if you have any questions regarding our presentations, feel free to reach out.